Alright, so in the last one, we covered a little bit about how I would approach open source if I was starting again and the whole 3-step process. This video is actually a continuation of the last and the second last video, both of them together. This is the next part, right? So I will discuss more of a step 2 from that video, and then also the project bridge that I was discussing before that. I will take that as an example to do that, right? Just to remind, step 1 is essentially you pick up a project and product and or a project on GitHub and then start to build on top of that. That is exactly step 1. It doesn't you don't have to do a lot of stuff there. It just happens on its own accord. Alright, so I'll just show you what I was talking about. So we have been so I discussed a little bit about project bridge, what I'm doing, all of that. It's a short video, you can watch it, but this is one of those contracts there. This contract essentially checks for similarity between images, and you can set a threshold that your dataset in a particular folder should not have more than X amount of similarity when using embeddings from a particular model, right? That is the language that we're going for. So just to recap, the dataset found at this path when projected when extracted in the embeddings extracted and reduced to 64 dimensions from model ResNet 18 should not have more than 60% or similarity of 60, whichever metric you use. Right now I think I have been using what metric, let me see. I think these are like just let me, yeah, L2 distance is essentially, I think yeah, Euclidean, but doesn't matter, like this distance doesn't matter. We can just add this again to here so that users can also specify the metric like this, but let's do that later. This is very untidy. I have to clean this up, but I'm just giving you an example, right? So what I was wanting to do in this video is, so earlier I was using Face by Facebook for this, and now I want to use LansDB, which looks super cool and it's super easy, right? So what I've done here is I've gone through LansDB, and then I found this documentation, and here is embeddings. So the example here gives us some idea how to get embeddings. So we need an embedding function that takes a batch and then returns that the embeddings for that batch. Essentially here you get a list and then you should return a list of embeddings for each element of that list. There's an example for sentence transformer, there's an example for OpenAI. And then they give you this example. You essentially have data frame where there's this text column, and you pass this to with embedding. So it takes a function and the data frame on which you want to operate, and then this with embedding function extracts the text column and then passes that text column as the batch here. Now there are some details about how it works. You can also specify the column if your default column is not text, which let's come to that. And then by default it will call the function with batches of 1000 rows. This can be configured also with using batch size. We need this much is okay. So we have this function called get embeddings that takes image paths, and then it opens up that image path, and I'll show you how this was before. Okay, so if I come down here, so earlier I did not have the image paths. It would just take the self.path path, and then that would create the entire image directory in a list, but we don't want to use that because with embedding function from LansDB, sort of, I think it parallelizes it or does something, does some sort of parallel processing, so it speeds up because it passes batches of thousands, right? So I'm assuming there's something going on there, so let's just use that format, right? So we replaced that, we moved that logic below right here, so that now I create my list here in the N4 section and then pass it in get embedding function, right? That's essentially what's happening here. And then I load that image, pass it to a tool that creates vectors from images and takes the model, and runs PCA to get to dimensional reductionality to this particular dimension as mentioned here, and then returns them in a list format, right? Okay, now what do we do next? So let's look at the changes again. Again, it's super simple, super untidy. I will tidy this up. So here essentially I've moved the image path creation here. I have gotten the data set. Actually we don't need that. I was just designing it. We might do that. Now here comes the part that I think could be improved, but maybe I'm wrong because I have just started using the tool, but this is my opinion, right? This is how it's done. The step 2 is, well, I'm looking at this and I'm seeing, all right, by default it looks at text, so I need this text column and pass my image paths there. That's the easiest way I can work with it. What I can also do is I could just say img paths and describe the column to look for here is img paths, but I mean it just is an extra step, so why should I do that? So I'll just leave it to text. So my feedback number 1 here is, well, we should name it something generic like data. So maybe this function should by default look at 2 things, which is, if they just have to look at one thing, let's just look at data, because vector embedding is not limited to text, it can be anything these days. And the second feedback is, if it has to look for text, then to avoid breaking backwards compatibility, let's look at 2 things, first text and then data. If both of them are not found, then probably do something, handle the error, or if both of them are found, text takes the higher precedence. Okay, that is my feedback number 1. All right, now let's look at this function with embeddings. So what I will do is I'll try to, I don't know why my Pydantic or whatever is not working. It should open this up just by clicking control plus click there, but it's not working. So I'll probably open this up through this environment, right? So I'll just visit this function to see what's happening in there, and I see something here. Okay, this is my lansdb embeddings. Okay, with embeddings what it does is it all right, it takes the function, it wraps it around. I don't really want to know what this does. I'll just assume that because it needs to call this function over again, it just wraps it inside its own class. I don't care what it does right now. It just does somehow facilitates processing this class. I don't care about this. Again, wrap API, I don't care about this. This is sort of like rate limit and stuff. Maybe it's again related to the performance improvement. Maybe they're parallelizing it in some way or whatever. I don't care, right? Again, this is about the batch size. By default it's 1000, so maybe they are breaking this up into 1000 and seeing how many calls they need to make in parallel or in whatever situation. Again, show progress, fine. Now here's the part, if data is an instance, pd.data frame. So if we get a data frame, we convert that from oh, by the way, I edited a little bit. It should not be like this. I was just playing around with this. So okay, if it's defined as a data frame, we will convert that to PyArrow, which is, again, arrow is faster processing, tabular processing stuff, and this is something that I added while I was playing around with this. Right, now what they do is they pass this data.column and then convert it to numpy, and then that, again, all this I have added while I was playing. You get the embeddings, then you convert that from vector to table. Now let's see what this function does. This function creates a PyArrow table containing vectors. So it needs, okay, dict, list, and array. All right, and then returns PyArrow table. Okay, perfect. So this is, all right, this is where we are right now. So we took that column, we created a embeddings table from that function, and then converted that to PyArrow table, and then appended that to the column, to the data frame, and with a name vector. Right, now I think this should be good. Let's see if we can work through this. So we have created the data. We now need a URI because again LanceDB is serverless, so we need just a temporary location where it can sort of create the database. We connect the DB to that URI, we create a table called similarity and pass it that, and now let's see if we can actually start to search for stuff. Okay, so what I'm going to do is I'm going to do table. I've just set up break here. Okay, I'll probably have to go up here. All right, let's see what table is. Need to exit. Okay, let's run this up again. And oh, okay, yeah, let's search for, okay, I cannot search for anything because I don't really know, but what I'll do now is I'll go here and run this again, and I should oh yeah, so I'm overriding that, so it essentially complains. I think there is a way to not do that, but I will not care about that right now. Okay, now if I do table dot let me just print the table first. Okay, and then I know that this is a vector space, so I'll just search for this particular vector, and then I will, okay, I shouldn't have done that. Now what I'll do is it should return a lance query. Okay, yeah, lance query, and then what I'll do is I'll do it to df, and it should arrange this table from the best matching to the worst matching. Now what I'll do is I'll set a limit to 1 because I need the closest one. The closest one in it should be itself, which is the same thing, right? So we build a vector search table using LanceDB essentially. Okay, now I can get rid of this. I have to create an index and stuff to be able to search approximate nearest neighbors, which is much faster and whatever, right? But I will figure that out, right? And let's see how it goes. But essentially I have two pieces of feedback now. One is to directly support, like, why would I actually need to convert this to a data frame? Why not just allow passing image paths? Because this step is just required to make my data compatible with LanceDB's with embedding function. So my first feedback essentially is to allow agnostic column names. So can be text and data, and then text takes higher precedence, and then the with embeddings function takes the list array, or like basically data types, popular data types directly, instead of being the user being forced to convert into data frame or pyro table. Again, I'm not very much familiar with pyro table, so it might be something else. All right, so like essentially what we can do here is we can support list or maybe even nd array. So now if this is instance data frame, you can write it from table. If is instance I don't know, data a list, you can then create another data frame. This simply you can just then support many standard data types. Like a lot of projects that are built in deep learning are not using tabular structure. So if you support that, it will be pretty easy. No one has to deal with panda stuff. Now that is one thing, and secondly, also, like, we can design this in a way that it's very user friendly. So if you get a list, we don't really know what the name of the column is going to be, so let's just name it data. So we create a pandas table or pyro table with the column name data, and then you, after adding the vector table, you can get two columns, data and vector. This is vector that is used to search, right? And then this will make it really easy for anyone to use it, because the thing is, converting to list numpy array and tensors, interconverting between them is pretty easy. Once you have a tensor, you can just do tensor dot numpy to get a numpy version, or you can just do list to get a list, and then you can interconvert them, because you can create dots dot from numpy and create a tensor, things like that, right? So it's very easy, it's very handy. So this is my feedback. Should I raise an issue? So I have just raised an issue. Now I'm realizing that I could have, like, the solution to this is maybe just calling I don't know where it is, this vector table, because then it should probably, yeah, so it probably takes, but again this is also not a full solution, because let me see, dd, yeah, so it's a dictionary. Why do I need to convert it in dictionary if the program can already handle it? So what I've done is, here is I've raised an issue here, support for native or numpy list with embedding function. So give them a bit of context, whatever. And the first feedback is the with embedding function takes a data frame as an optional column name which is fixed to text. Have you guys thought of either using a more task agnostic name or searching for two keys where text has higher precedence? Secondly, have you thought of allowing more input types? Currently it is input data frame to output data frame, but maybe instead of standardizing both input and output data frames, it's better to only keep output format fixed essentially, and keep input more flexible, which is allowing data frame, list and another objects, and then keep the output exactly standard. So it's like, well, if this function takes so many arguments, so many different kinds of data types, but it gives me a standardized output, this is more sort of powerful than fixing both input and output. This is what we've done with Ultralytics YOLO package, which is, it can support a lot of different models, but the results, the output is pretty much the same API. So no matter if you're using SAM, Dino, I mean, we're not using Dino yet, but YOLO V8, YOLO V5, whatnot, you'll get the same output structure, even though you're using different models, right? So in case of a list and maybe np.array, the input and output can be a data frame with columns, data, and vector. Data we have just chosen a name because it's very agnostic, right? Alright, so the difference is not very, it's not a stark difference, but the thing is, users will be able to use it without visiting docs, which is a good thing, right? And you don't have to convert a data set into, I don't know, data frame. And if you're not used to dealing with tabular data like myself, you don't really appreciate being forced to use tabular data set. So I have my image paths, I get them like this, and I have to convert them to data frame, which just goes away with embeddings function, right? Alright, and I also mentioned that I might have missed something obvious because, I'm just getting started. But this is like one thing. Like, now I've opened this up. If they like it, maybe we'll move forward and it's a valuable contribution. If they don't like it, they'll just tell me the reasons why this is not a good idea, and they'll close this. But it's one way to get started. Like, this is step 2. Now step 3, or maybe step 2 part 2, is I build something and I finish this up, and if it's a really good, if it turns out really well, I can showcase this, right? And then in step 3 is they actually agree that, okay, this is something worth doing, and then I volunteer to do it, and that is how this becomes a contribution, right? This is how I would go about with any open source contribution. A live example right in front of your eyes, and I don't know, like, this might even just get shut down, like no one would merge this, no one would like it. That is fine, because that is how you get started, right? So yeah, there's no easy way. There's no like, okay, I started today and I'm a well-known contributor tomorrow. This is the process, and trust me, this is the only process that I know of, and I'm pretty sure that there are no other ways that I would vouch for. So yeah, this is it for this video. I'll make more videos about actual contributions to YOLO V8 as well, and how to navigate the file structure. But yeah, this is how it goes, and I think that's it for this video. I think I might have run over time with this one, but I don't know, let's see. All right, that's it. Bye bye.